Hello, everybody. We're going to be doing the third lab, Projectile Motion. We're going to be doing the no computer version. Okay, so on Blackboard, I think this shows up as lab 4, but it's actually the third one we're doing. So, and it will say right at the top, no computer version. So I have the setup here behind me where we're going to be launching the steel ball. And the reason I have the book there is so that we're ending at the same vertical elevation or very close to it. Okay, so the data that we're going to be collecting for this initial trial is for tables 2 and 3. We're going to be measuring the time that the steel ball is in the air, and we're also going to be measuring the distance, the X or the range that the ball travels while it is in the air. So the first setup here, I have it set up at 30 degrees, which is the first set of data. And I have a piece of carbon paper. So what's going to happen when the steel ball hits the carbon paper is it's going to leave a mark, and we're going to be able to measure a distance from that mark. So I need to locate the steel ball. So here we go. The ball should land on the book. So this is the first trial at 30 degrees. So we're going to be measuring distance only. Okay, so here we go. Okay. Now I'm going to come over, and there'll be a little black dot here on the top of the paper that I'm going to measure that distance. So your first distance is 2.275 meters. So 2.275. And what I'm going to do on the paper is I'm also going to mark on here this was my first data measurement, so I don't accidentally measure to this point again. So this was 30 degrees, trial 1. And I'm going to put my carbon paper back down. This is the second trial at 30 degrees. Back. 30 degrees, trial 2. So the marks are very close to one another, which is a good sign. So the second trial is 2.282, so 282. So the first one was 2.275. The second one is 2.282. 2.282. Okay. So a little less than 2.3 meters. Third trial. It is a bit handy that my file folders are kind of acting like a little catcher's mitt here at the end of my setup. Third trial. At 30 degrees. What's interesting is it's extremely close, almost right on top of my mark for my second trial. A little bit past it. So it's 2.285. 2.285. So then the third column, it asks you to take an average of those distances, those three distances. And then the last column, there's an equation in the textbook that I want you to look for, that given some starting angle, some launch angle, and some range or some distance, you can calculate initial velocity. So I want you to look for that in the textbook, and that's what you're going to use for this last column, V calculate. Now, before I change the setup and change the angle, that's table 1. If we look at table 2, table 2 asks you to measure the times. So before I change the setup, I'm going to get a stopwatch and I'm going to measure the time it takes from the time I release it until the time it hits. The third version of this, we're going to do another version of this lab where we're going to use photo gates to measure the time. But for this trial, what we're going to do is we're going to measure time using a stopwatch. So the next trial, it's going to be quite a bit more accurate. And I'm not really worried about the range, so I'm not going to be measuring that. I'm just going to be measuring flight time, how long the steel ball is in the air. Okay. That was in the air 0.56 seconds, 0.56. Call that 0.42 seconds. that one's 0.45 seconds. Then you've got 3 columns for measured times, which we just did. Then you have a column for experimental average. Let's add those 3 up and divide by 3, so get your average that way. And then there's an equation that you can calculate your starting velocity v sub 0 from times. Okay, so you're going to calculate velocity based on time. So now I'm going to go back to table 1, and I'm going to change my launch angle to 45 degrees. Then what I got to do is do a test shot and see where the steel ball is going to land and move the textbook down. Look like I'm right around here. So 3 shots to measure the distance and then 3 shots to measure time. Tape measure squared away. This will be the first shot at 45 degrees. So distance 1 at 45. Is 2.612. 2.612. Second shot is 2.642. 2.642. This was my third shot. So the third shot is 2.618. 2.618. So now that fills out table 1 for 45 degrees. So again, you're going to do an average of the three distances. And then there's a range equation in the book that you can solve for velocity given the range and the angle. So now I'm going to take 3 times, or measure 3 times at 45 degrees. So I'm switching to table 2. Switching to table 2, and I'm doing the times at 45 degrees. That was 0.83 seconds, 0.83 for the first time. That one was 0.77, 0.77. This one was 0.85. 0.85. Okay, so those are the 3 times at 45 degrees. So we're switching back again to table 1. And we're changing the angle now to 60 degrees. I've got to adjust my launcher and increase the angle up to 60. And then we're going to do a test shot and see roughly where the ball lands so I can measure. We'll do a test, see if it lands on the textbook. Yep, lands on the textbook. Put my carbon paper down so I can measure my distance. Tape measure ready. Here goes first trial at 60 degrees. Okay, the funny thing is that it's too close to some of my others. So I'm going to spin this around and redo that because I can't really tell which one it was. Redoing that one. There we go. So the first distance, 60 degrees, is 2.195. 2195. $2.195. Second trial. $2.178. 2.178. Need my carbon paper. That one was 2.202. 2.202. Okay. So now we're not worried about distances. We took our three distances. We're going to switch over to table 2. So other than calculating your averages and your velocities based on starting angle and range, okay, table 1, the data that you need for table 1 is completed. So now table 2, all we need to complete this table is the times at this angle. So let's do that. Wasn't quite ready. Let's try that again. That was 1.05. 1.05 seconds. Now, you can imagine that when we do the computer-based timing with the photo gates, we're going to be getting a much more accurate measurement of initial velocity because it's measuring how long it takes that steel ball to strike a sensor or break a light beam on the sensor for the photo gaze. So you're going to get a much more accurate time, which is going to give you a much more accurate velocity. That was 0.99 seconds. So one more time at 60 degrees. .95 seconds. So now to complete table two, all you need to do is get your averages. And then from the times, you're going to calculate a different initial velocity. Okay. So then for question number 10, it asks you to determine the average velocity from the times and distance approaches. So under 10, the initial distance based is what you're calculating in table 1. The initial time based is the velocity you're getting from table 2. Now, we're going to take a look at tables 4 and 5. So, table 4 and 5. Table 5 is all calculations. Okay? It's all calculations based on the equations that you already used. It's based on other equations that are in the front of the lab. So you'll fill out table 5 using the data, but there's no additional data for table 5. For table 4, you'll notice that there's distances for 30, 45, and 60 degrees. What you're going to do is you're going to use your distances that we previously got for table 1 and use them for table 5. I am just going to do the launching for 15 and 75. And at the top of the page, if you read number 1 under launching the ball, it tells you use the data from before to fill in the remainder of table 4. So we're just going to do, distances and times for 15 degrees and 75 degrees. So I'm going to change my setup now. I'm going to change this down to, we'll do 15 degrees first. Okay. We got to do a test to see where the steel ball is going to land. So we'll do an initial test. We'll do that again because this is pretty flat. here. I think we're ready. Put our carbon paper down. So this should be the first distance at 15 degrees. One 1.572. 1.572. So that's the first distance at 15 degrees. One 1.578. 1.578. So this is the third and final distance at 15. One 1.568. 1.568. Okay. So now I'm going to measure 3 times. Actually, according to the table, all right, so we are not going to measure the times at 15 degrees and 75 degrees. We're only going to measure the distances. So the times that you're going to use down in table 5, those times are going to be calculated times. So you're going to use the equations to determine those times. So now we're going to change the angle to 75. Take 3 distances, and then you can measure, or you can do the calculations from there. Test fire and see if I need to move the textbook. Okay. We're ready for our first distance at 75 degrees. First distance at 75 degrees is 1.482. 1.482. Paper back. Shot. One point 536. 1.536. Okay, so this should be the last shot. Place my carbon paper so we get a mark. One 1.522. 1.522. So the rest of the data, like I said, is going to come from the previous tables. Table 5 you're going to fill table 5 in based on a combination of the previous data and calculations. For number 3, I'm sorry, on page 5, question number 3. It asks you, once you have collected all the required data, it asks you to set up a launch angle of 25 degrees and then calculate the distance to the cup. You're not going to do a practice shot and try and hit the cup, but I do still want you to calculate the distance to the cup given a launch angle of 25 degrees. You're also going to have to do some Excel plotting on this lab. So pay attention to where it says create a graph. That's what I'm asking you to do, is use Excel. I went over how to do that with a few people who have never used Excel before. And I'm also willing to help anybody out who still doesn't know how to use it. And then the rest is going to be questions. Assignment questions. If you have any questions, feel free to email me, or if you have Professor Miller, or if you have Professor Donnie, feel free to ask any of us questions, shoot us an email, bring your questions to Zoom. So the next lab we're going to do is going to be a very similar, if not identical lab, where we're going to be using a set of photo gates that are going to get attached to the launcher, where we're going to get the times using the photo gates. So that'll be the next lab. Okay, so until then, email us with any questions and have a good day. We'll talk to you later.